For that video I promised you, and we're going to go through some of the problems that we already went through just to reiterate what those formulas are and how to use them. It's just a problem solving section. If I have time, I may go through the true and false, but you already have the answers to it, so it should not be difficult. Let's just go ahead and start here. A skateboarder starts from rest and maintains a constant forward acceleration of 0.50 meters a second squared for 8.4 seconds. What is the rider's displacement during this time? So what are we looking for? Well, we're looking for final displacement, so x final. That's what we don't know. We're going to try and find out, right? Skateboarder starts from rest. Well, that gives us a lot of information. That means that his initial velocity, or their initial velocity, is 0 meters a second. There is a constant acceleration, which is what these formulas are used with, constant acceleration of 0.5 meters a second squared. And then last but certainly not least, we're given time. Time is 8 4/10 seconds. Great. Now, if we have x final, there's only one of the big three that gets us there, right? Well, that formula is, let's write it in yellow, bright as day, x final equals x initial plus initial velocity times time plus 1/2 acceleration times the time squared. Now there are a couple of things that we can get rid of in this formula for this problem. One, there's no initial displacement, right? It's not listed, it wasn't given to us in the problem. So I'm just going to get rid of that. Since our initial velocity is 0, it doesn't matter that we're multiplying that 0 times 8.4. Anything multiplied by 0 is 0. So far, all we have to do is solve the 1/2 at squared piece. Well, 1/2 times, well, this is also 1/2, but it's in decimal form. And I'm sorry, I forgot to put the units there. Meters a second squared times the time squared times 8 4/10 seconds squared. And if I get out my handy dandy calculator, I already have that information, right? If I can scroll up. Rats. So 8.4 squared is 70 56/100ths. So this value right here squared, 8.4 seconds squared, is 70.56 seconds squared. Very important to have seconds squared here. Why? Because I'm going to multiply 1/2 by 1/2, and I'm going to come up with 1/4, right? Because 1/2 times 1/2 is 1/4, or 0.25 meters a second squared. Now, this second squared cancels out with this second squared, and I'm going to be left with meters. You know, the only unit I'm going to have at the end of this is meters. So 70.56 times 0.25 gives me an answer of 17.64 meters. And I can leave it like this because I'm looking at the two decimal places, and there are two decimal places up here, so I can leave it just like this. I don't have to round to anything. Right, so that's the answer to the first one. That's how you get there. There's your formula. By the way, you're going to use the same formula in the next one. But we have to use it in a different format, right? I mean, we're only given a certain bit of information. So what I'm going to do is I'm going to use that same formula. A sports car moves 100 meters forward in the first 4.5 seconds of constant acceleration. All right? We have to assume, and I think I'll type it into the problem itself when I give it to you, that initial velocity is still 0. And then we're given XF of 100 meters, and we're given a time of 4.5 seconds. Can't see that decimal, 4.5 seconds. Now we're going to use the same formula, but we're going to solve for something different. We're solving for acceleration. We don't know that just yet. So that's our unknown. I'm still going to use x final, and there's no initial displacement, so I'm not going to put x initial up here. I'm not going to, we don't have an initial velocity, which is 0. Pardon me. So I'm going to leave that out because 0 times 4.5 is still 0. So all I'm going to deal with is 1/2 a t squared. Now, here's my problem, right? I'm not solving for final displacement. I have that number. I need to solve for acceleration. It says, what is the car's acceleration? So what I'm going to do is I'm going to multiply by 2, because that gets rid of this half. Right, so multiply by 2, multiply by 2. This cancels with this. All right, so now I have 2 times my final displacement equals a times t squared. Well, you know, if a, acceleration, what I'm solving for, is being multiplied by t squared, let's go ahead and divide by t squared. And so that's what I get. I get a, my acceleration is equal to 2 times that displacement divided by the times squared. Sorry about that. 2. Oof. There we go. So it's even worse. Anyway, let's go ahead and do that first part. There we go. So I want to find acceleration, and I have 100 meters, and I have 4.5 seconds. Here we go. Dun, 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 2 times 100 meters divided by 4.5 squared is equal to 200 meters. Over 20.25 seconds squared. And when we divide 200 by 20.25, we get 9.9 for A. All right, so there's the first part. My acceleration is 9.9. And then we had these units here, meters over second squared, meters per second squared. All right, so the next part is drawing a velocity time graph. And I can go ahead and change the colors here. Maybe this will show up. I don't know if this will show up. But I want it to be super duper simple. I don't want you to overthink this. I want you to just make this as easy as possible. And this is, oh, I forgot to get rid of this, sorry. This is 10 meters, 20 meters, 30 meters, 40 meters, let's say 50 meters. 50 meters a second, right? Because we're looking at a velocity time graph, so V and T. Then we're going to say 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. And then we have got, in the middle here, we've got 4.5. And we're going to be just here. I'm going to rough it in here. It's going to be about 45, 44-ish. So what we want to do is we want to go ahead and connect the dots from here to here, right? And this is basically my acceleration, right? The slope of this line is acceleration. But if you look, it's just 9.9 is almost 10. So 1 second is just about 10 meters a second. 2 seconds, just about 20 meters a second. Just about 30, just about 40, just about 45. So what you need to do is tell me that the slope of this line, m, equals 9.9 meters a second squared. Cool? Excellent. Now we're going to move on to the next question. A ball has an initial velocity of 1.6 meters a second. It has an acceleration of 33 100ths meters a second squared in the same direction. And what is its speed after 3.6 seconds? So what do I have? I have an initial velocity. That initial velocity is 1.6 meters a second. Next, I have acceleration. They've given me acceleration, constant acceleration of 33 100ths meters a second squared. Last but not least, they give me time, and the time is 33 6/10 seconds. Right? So this is super simple. If the ball has constant acceleration in the same direction of movement, what is its speed? So we're going to look for a velocity formula. So VF equals VI plus A times T. And we have all of those things. We have VI, we have A, and we have T. So I'm going to go ahead and start working on this. Let's plug in some values. VF is equal to 1 6/10 meters a second plus 33 100ths meters a second squared times, sorry, I ran out of space. I'm going to just put it right down here, 3 6/10 seconds. All right. And I'll use more space out here. I want to look at these two things. This 0.33, you can use your calculator and go ahead and do this multiplication, but 0.33 should trigger something in your head. It's very much like a repeating 3, you know, and that is 1/3. So if you want to multiply this by 1/3 or divide 3.6 by 3, you know, you can do that. And what you would come up with is something that's somewhere in the neighborhood of 1.2 meters a second, right? This second's going to cancel out with the square there. And then we've already had that 1.6 meters a second. So you put these two things together and you're going to get a final velocity. And we're not going to be done. We have another section to do, but our final velocity, which is going to help us in the next section, is 2 8/10 meters a second. So now we're asked, how far did that ball travel? Okay, well, we have enough information in front of us. Even with VI and A and T, we could have figured this out. You know, we're so used to using that gosh darn formula for displacement, we're going to do it again. So I'm going to write the formula for displacement, which is x final. Oh, I shouldn't use yellow. Sorry about that. Let's get rid of it. Can't see the yellow on it. So let's go ahead and use something dark. X final equals x initial, but there's no initial displacement. It doesn't say anything. VIT, initial velocity times time, plus 1/2 times the acceleration times time squared. So this is going to help us out quite a bit. It's going to be really, really, really simple. Let me go ahead and write out everything as we see it. So x final, part B, is initial velocity 1 6/10 meters a second, 0.6 meters a second, times our time, which is 3.6 seconds, 3.6 seconds. That second's going to cancel out with that second, and we have meters. We are on the right track. Plus 1/2 times 0.33 meters a second squared times 3.6 seconds, and then square that. Now, it's a lot of work here. I'm going to use, please excuse my dear Aunt Sally, and I'm going to square 3.6. And that comes to 12 and 96/100ths seconds squared. Now, that's going to be multiplied by 1/2, which in turn is multiplied by 33/100ths meters a second squared. Right? And if I do all of this, this value times 1/2 times 0.33, I get approximately 2 14/100ths. Where did that go? There it is. I don't know what just happened to my computer, but please, please don't be mad that it went away. I can't go back and start over again. It's much, much too late in the day, and I can't. I'm going to ignore that. 1.6 times 3.6. Sorry about all that garbage. These two things multiplied together is 5.76 meters. And now I just get to put these together, and that's going to give me my final distance, or my final displacement. So 7 9/10. Oops. Let's undo that. 7 9/10 meters. Well, there's something funky going on with my computer. All right, there we go. Sorry about that. All right, last question for anyone who's not in an honors class, and this is the problem I told you that I usually put on a test, and here it is. I'll give you the formula, and you will be able to do that. Sorry about the school bell. There it is. All right, a squirrel drops an acorn from a tree branch that is 8 meters from the ground. How long is the acorn in the air? So what are we looking for? We're looking for time. We don't know how long it takes. Are we given an initial velocity? Well, yeah. The squirrel drops the acorn. And in a question earlier, it says the kid drops a ball. What's its initial velocity just as he drops the ball? So its initial velocity is 0 meters a second. Good. What else do we know? We know its height, right? It's 8 meters from the ground. And lastly, we're trying to find the time. Do we know the acceleration? Well, do we know acceleration? If somebody drops something from a height, what is the acceleration? And our acceleration is 9.8 meters a second squared. Oop, gravity. Right? Okay, so we're obviously talking about free fall, so here we go. Since we know our final displacement and we know our initial velocity, there are a couple of ways that we could do this. We could use either formula solved for time. But we're going to use our tried and true x final equals 1/2 at squared, okay? And we're going to solve for t, right? Not t squared, we're going to solve for t. Because I have a distance, a height, and I have acceleration, and I'm looking for time. If I put that VIT in there, I'd just be multiplying by 0 again. So I'm not going to put it in there. So I'm going to solve this for t. And the first thing I'm going to do is multiply by 2. So 2, that cancels out with that. And I have 2x equals a t squared. Well, I'm going to divide by a. And what do I get? I get 2x over a equals t squared. And how do I undo that square? I take the square root. So I leave this under the square root. The square root of 2 times the height divided by gravity is going to give me my time in free fall. So let's go ahead and do that. And I'm going to need time so I can find out what the acorn speed is in the next part. So let's go ahead and put that in. I have 2 times 8 meters over gravity, which is 9.8 meters a second squared. And so I'm going to move this over here and say this is the same as 16 meters divided by 9.8 meters a second squared. Why didn't I make gravity negative? I hope some of you have asked. You don't need to make gravity negative because the acorn is only going in one direction. We haven't thrown the acorn up to come down. So either way, we would have been okay. We would have had a displacement of negative 8 meters if we made downward negative. I don't want to confuse you. 16 divided by 9.8. Let me put that into my calculator. And what I get is the square root of 1.63 equals time, and then I take the square root. And the time in the air is about 1.3 seconds. It's 1.2 and change. I could have said 1.28 seconds, but I like a nice round 1.3 seconds. And why do I need that? Because I need to know how fast this object is going before it hits the ground, right? So the next part goes with this. Sorry about that, that line. It was horrible. But letter B is going to use the formula V final equals V initial plus A times T. Well, we already said the V initial is 0, so I'm going to get rid of that. I'm going to Ignore it. So acceleration, gravity, times time, 1.3 seconds, is going to give me my final velocity. So 9.8 meters a second squared times 1.3 seconds is going to give me my final velocity. And of course, the seconds cancels out and gets rid of that square. And now we have meters a second as our unit. 1.3 times 9.8 is 12 point. Hey, I've done this before. 12 and 74 100ths meters a second. If you wanted to make it 12.7, I think that's okay. But I think, yeah, that's the only thing I have that gives me decimal places. So it says round to 2 decimal places because that's what our meter stick is using. Our meter stick is working with millimeters. Good? But it's actually working with centimeters, right? Hundreds? Sorry about that. Here we go. That's the answer. Let's move on. Last one. This one is the same thing, except it'll make life a little bit easier, right? This one is a lot of fun. How long does it take to get up to its highest point? Great. So we said, and I quote, we have an initial velocity, right? Our initial speed is 45 meters a second. So to reach its highest point, remember our speed at its highest point is 0 meters a second, right? Gets up to the top, stops, and then comes back down, right? So that's easy. And then we're looking for the time it takes. All we need is acceleration, which is negative 9.8 meters a second squared. And time is what we're looking for. Great. This is the old tried and true, the original bad boy. I don't know what else we would call it. We're going to use V final minus V final equals V initial plus AT, right? Solved for T. Remember we did that? So we did that in class. So suffice it to say V final minus V initial divided by A gives me T. So we're going to use this formula. When you're talking about up and down motion, we usually just say 2 times the initial velocity divided by gravity. That doesn't really work here because our final velocity is 0. So I'm going to actually do this problem right underneath here. So 0 meters a second minus 45 meters a second divided by negative 9.8 meters a second squared. So 45 9.8. And this time is just about, what did I say, 4? That was horrible. It's just about 4 and 6 tenths seconds. So heading out at this really fast speed, 45 meters a second, it gets shot straight up into the air, and it takes 4 and 6 tenths seconds to get up to the top to come to a stop, right? Well, let's find out how high it gets. Now, don't forget, we're going to use that third formula. Have you noticed that I've avoided us using that second formula because it's so annoying? But we want to know how high it gets. There's no initial displacement, right? So I can write it here, but I'm not going to use it. There is an initial velocity, right? VI, and we have time now. And there's 1/2. We do know the acceleration due to gravity, and we still have time. So let's go ahead and use all of that information to get us from the beginning to the end. Let's use this color here. So I want to know what my top height is, and let's just start using that. 45 meters a second times my 4 6/10 seconds plus 1/2 times 9.8 meters a second squared times 4 6/10 seconds, and square that, right? And so I can start doing 4.6. So 4.6 squared is 21.16 seconds squared times 1/2 times 9.8 meters a second squared. And let's do this. 45 times 4.6. 45 times 4.6. Wow, 207. 207 meters. That's way up there. That makes sense. All right, so it would go up 207 meters. What we're going to find is that this is going to be somewhere around 103, between 103 and 104 meters. All right, trust me on this one. I've done this before. It's going to be between 103 and 104 meters, but it's going to be negative because gravity is negative. Remember, this is an up and down problem, so up's going to be positive, and down's going to be negative. All right? And I wrote it over here. I don't know why I didn't write it over here. So let's do 1/2 of negative 9.8 is negative 4.9 meters a second squared times 21.16 seconds squared. And let's just do that. Negative 4.9 times 21.16. And get that. And believe it or not, it's between 103 and 104. It's negative 103.7. All right, so 207 plus 103.7 gives me just about 103 3/10 meters. Really, it should be about 103.5, but because of rounding, you sort of lose a little bit of your accuracy, your precision. But if you get somewhere in here between 103 and 104, you are killing it. All right, that's my final problem. That's it. Thanks for your time. Good luck tomorrow.